All right, this is very sensitive, so I'm going to move it back a bit. Well, I wanted to welcome all of you to the third and the last lecture in a series of lectures begun last spring. This is a series on the relations between science and religion. My name is Dr. Thomas Riva, and I'm the Director of Religious Studies and the President of the Aquinas Educational Foundation. It's my pleasure to welcome Professor Stephen Barr to Purdue. In a moment, Professor Birgit Kaufmann will give the formal presentation and formal introduction to Professor Barr, but I have to have a word first. Tonight, my function is twofold: to thank the organizations and institutions which have made tonight's lecture possible, and to describe the order of this event. Any lecture of this sort has many moving parts, and all of the following organizations and people have helped to put these parts in motion. First, I'd like to thank Father Tom McDermott for his involvement at all stages of tonight's lecture, but especially for making the church available for today's Gold Mass, reception, and lecture. Second, I'd like to thank the sponsoring organizations, the John Templeton Foundation, the Aquinas Educational Foundation, the Program of Religious Studies in the School of Interdisciplinary Studies at Purdue, the Society of Catholic Scientists, of which Professor Barr is president, and the St. Thomas Aquinas Center. Third, I would like to thank the people behind the scenes: Mary Black, Kaylee Scott, Beth Facemeyer, and Sam Haas-Stetler for helping with advertising and logistics. My second function is to describe the order of what will happen next. After Professor Kaufmann introduces him, Professor Barr will speak for about an hour, after which he'll answer questions for about 20 minutes. Students are now distributing evaluation forms for tonight's lecture. I ask you to complete those forms immediately after the question and answer session, or if you have to leave earlier, right after the lecture itself. Hand them back to the students with the pencils after your departure. Thank you very much and welcome.
So, good evening, everybody. It is my great pleasure to introduce Professor Stephen Barr. He is a professor emeritus at Delaware University, and his field is theoretical particle physics. So starting from a PhD in Princeton University, he has had a very successful scientific career. He has made important contributions to his field about CP violation, grand unified theories, and baryogenesis. He was elected Fellow of the American Physical Society in 2011. He was also the director of the Barr Research Institute, which is a scientific research institute at the University of Delaware. In addition to his scientific work, he also wrote and lectured extensively about science and religion. He wrote numerous articles which were published in First Things, an ecumenical religious intellectual journal, and other journals like Commonweal, National Review, Modern Age, The Public Interest, America, The Wall Street Journal, and other publications. He authored books entitled Modern Physics and Ancient Faith and The Believing Scientist: Essays on Science and Religion. He was elected to the Academy of Catholic Theology in 2010 and received the Benemerenti Medal in 2007 from Pope Benedict. He is the president of the Society of Catholic Scientists. It is a great honor to have him with us tonight, and I'm looking forward to his talk, Science and Religion, the Myth of Conflict. Thank you very much.
Let me make sure I don't speak too loud. Is this adequate right here? Okay, thank you, Tom and Birgit, and thanks to all, and Father McDermott, and all who were involved in setting this up and inviting me here. And thanks for coming out to hear me tonight. Before I begin, how many people know who that gentleman standing with Einstein is? Raise your hand if you know who that is. Okay, I'm glad that not many hands went up, because that means you'll learn at least one thing tonight. So many people think there's a conflict between science and religion. And I'm sure that most of you are aware of this, and maybe that's why you came out to hear me tonight. When people find out that I am a scientist and that I am religious, They sometimes ask me whether I find any difficulty in reconciling the two. I've always found that a strange question. I'm a scientist for many of the same reasons that I am religious. A sense of wonder, a passionate desire to know the reason behind things, and a belief that there is a reason behind things, and that everything holds together in some coherent way. For me, both the Catholic faith and modern science make sense of the world. Science tells us about the things we can observe and measure. Religion has a much wider scope. The Catholic faith has a much wider scope and answers deeper questions. Questions about the ultimate cause of the world's existence and order, the purpose of human life and our ultimate destiny. It tells us about spiritual realities, about God and man, love and truth, good and evil, sin and redemption. The Catholic faith and empirical science are two perspectives on reality. They see things in different ways, but not necessarily in conflicting ways. I've been a Catholic for 68 years. I'll turn 69 at the end of this month. And I've been a scientist for over 44 years, and I know of no scientific fact or well-established theory that conflicts with any authoritative Catholic doctrine. So why do many people think that science and religion are at odds with each other, inherently at odds with each other? There are several reasons. Some people have misconceptions about science and what it has discovered. And many people have misconceptions about what various religions actually teach. This is certainly true of Catholicism. Not even all Catholics have an accurate knowledge of what their own faith teaches. Some people just lump all religion together in an undifferentiated mass. Every example of a superstitious belief or magical practices that they come across is therefore evidence to them of the irrationality of all religion. A very common error, and many of the new atheists make it, is a failure to distinguish between science itself and a certain philosophy that is often called scientific materialism. What is scientific materialism? Materialism is the idea that all reality is reducible to matter and its behavior. Scientific materialists are people who think that materialism is somehow implied by modern science. Now, this is an opinion that is held by many scientists and by many people who claim to speak in the name of science. But it is no claim to being science. It is a philosophical opinion. Now, if matter were the only reality, then of course God would not exist, because God is not a physical entity. Nor would human spiritual souls. A human being would be nothing more than a complex structure made of atoms. And everything about a human being and human being's behavior would be ultimately explicable in terms of the laws of physics that govern how the atoms in that human being move. In other words, scientific materialism implies not only that God does not exist, but that, strictly speaking, you don't exist, not at least in the way that you thought you did. So, for example, the popular astronomer and science writer Carl Sagan said in one of his books, "I am a collection of water, calcium, and organic molecules called Carl Sagan." Francis Crick, co-discoverer of the structure of DNA, wrote in one of his books, "You, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. As Lewis Carroll's Alice might have phrased it, you're nothing but a pack of neurons. Now, that is the materialist view. Now, for some of its adherents, scientific materialism is more than just a philosophy, a philosophical stance. It's a passionately held ideology that sees science as having a saving mission. And that mission is to free the human mind from superstition and irrationality in all its forms, and they count religion as one of its forms. For such people, it's not enough that science is good and brings us understanding of the world. There must be an enemy to be vanquished, and they cast religion in that role. They see themselves as taking part in a grand struggle between reason, represented by science, and its enemies, which includes religion. Those who say that science and faith are in conflict have three kinds of arguments that they typically make: philosophical, historical, and scientific. Their philosophical claim is that there is an inherent contradiction between the scientific and religious outlooks. Science is based on reason and evidence, whereas religion, they say, is irrational because it is based on dogma, faith, and mystery, which involve belief in things that cannot be seen and for which supposedly there is no evidence. Science is based on natural explanations and natural laws, whereas religion is based on miracles and the supernatural. They see religion as a matter of myth and magic, and therefore the very antithesis of a rational scientific outlook. So apart from anything that science has discovered, the very outlook of science and religion, in their view, are antithetical to each other. Their historical claim is that religious believers and institutions have been hostile to science and have tried to suppress it. This is powerfully symbolized in the eyes of many people by the Catholic Church's treatment of Galileo 400 years ago. And this impression is constantly reinforced in the public mind by the never-ending battles against evolution waged by fundamentalist Christians. The materialist scientific claim is that the actual discoveries of modern science over the last 400 years have debunked or undermined basic Christian beliefs about the universe and humanity's place in it. As the story is often told, and this is the story I was told when I was a kid, science has dealt one blow after another to the religious conception of the world. Copernicus showed that the human race is not at the center of the universe. Newtonian physics showed that nature has no purposes or goals, but is purely mechanical and governed by blind and impersonal forces. Modern astronomy showed how small and insignificant we are compared to the cosmos as a whole. Darwin, some say, showed that human life is an accident and that human beings differ only in degree from lower animals. Advances in neuroscience and artificial intelligence are thought to be demonstrating that the supposed soul is nothing but the working of the brain, a complex biochemical computer. Modern cosmology is invoked to show either that the universe had no beginning or that the universe created itself out of nothing by a quantum fluctuation. In this talk, I'm going to focus primarily on the materialist philosophical and historical claim that religion, and the Christianity in particular, are inherently contrary to science and historically have been its enemies. In the last part, I'll discuss some of the things that modern physics has discovered and argue that they're more consistent with what Christians and other theists believe than with materialism and atheism. So let's begin with the supposed opposition between the supernaturalism of religion and the naturalism of science. It's certainly true that biblical religion and most other religions involve belief in supernatural entities and events. However, the biblical religions have never been based on supernaturalism, if we mean by that a rejection of the idea that there is a natural order, that there are natural phenomena and natural causes. In fact, scholars tell us that the book of Genesis was in part a polemic against, an attack on, the supernaturalism and superstition of ancient pagan religion. When Genesis said that the sun and moon were merely lamps or lights placed by God in the heavens to light the day and night, it was responding to pagan religions that worshiped the sun and moon as gods. When Genesis said that man is made in the image of God and is to exercise dominion or stewardship over the animals and other created things, Genesis was, among other things, attacking or opposing the pagan religions in which human beings worshiped and bowed down to animals and created things, or to gods made in the image of animals and created things. In paganism, the world was filled with occult forces and populated by numerous deities, gods and goddesses of the oceans and the forests, of wind and fire and lightning, of sex and fertility, and so on. Jews and Christians, however, taught that there's only one God who is not to be found, is not to be sought within the phenomena of the natural world, within its forces, but a God who is above the natural world, who is outside of nature, who is indeed the author of nature. So, biblical religion had the effect of stripping the physical universe of divinity and making it into a natural world, no longer the abode of gods, but simply the creation of the one God. And since God is good, the natural world was seen as something good and worth studying. And since God is intelligent and wise, the world he made must reflect this. It must therefore have been made according to principles and laws that can be discovered by and understood by reason. Biblical religion taught that there is a natural order which comes from God, and that what characterizes this natural order and reflects the rationality of its creator is precisely that it is orderly, harmonious, and lawful. Consider this passage from the letter of Clement to the church in Corinth, written about 97 A.D. St. Clement was a bishop of Rome, listed in ancient documents as the third after St. Peter. We mention him in the Mass: Linus, Cletus, Clement, Sixtus, Cornelius, and so on. So in this famous letter, written in 97 AD or so, to the church in Corinth, this is a small excerpt. He says, "The heavens, as they revolve beneath his government, do so in quiet submission to him. The day and the night run the course he has laid down for them. Sun, moon, and the starry choirs roll on in harmony at his command, none swerving from his appointed orbit. Laws of the same kind sustain the fathomless deeps of the abyss and the untold regions of the netherworld. The impassable ocean and all the worlds that lie beyond it are themselves ruled by the like ordinances of the Lord. Upon all of these, the great architect and Lord of the universe has enjoined peace and harmony." Or consider this passage from the Christian author Minucius Felix, writing around 200 AD. It's in a book that was addressed to his pagan contemporaries to convince them why they should believe in a creator God. And he says, if upon entering some home, you saw that everything there was well tended, neat, and decorative, you would believe that some master was in charge of it and that he was himself much superior to those good things. So too, in the home of this world, when you see providence, order, and law in the heavens and on earth, believe that there is a Lord and author of the universe, more beautiful than the stars themselves in the various parts of the whole world. Look at what these two passages that I've quoted point to as evidence of God, not to supernatural phenomena or miraculous departures from the order of nature, but to the order of nature itself. This was actually the standard argument given by ancient Christians for believing in a creator God. This and the very fact that there is a universe at all. In the two classic arguments based upon the physical universe for the existence of a creator God were first that the universe exists and second that it is orderly. Allow me to, so there's a cause of being and there is a cause of order. So I'm going to quote about 7 or 8 early Christian writers to show how standard this line of argument was. St. Gregory of Nazianzus in the late 4th century wrote, "Let us even suppose that the existence of the world is spontaneous. To what will you ascribe its order?" Origen, writing around 250 AD, says, "When we are convinced by what we see in the excellent orderliness of the world, then we worship its maker as the one author of one effect, which, since it is entirely in harmony with itself, cannot therefore have been the work of many makers." Lactantius, writing around 300 AD, says, "There is no one so uncivilized nor of such barbarous manners that he does not, when he raises his eyes to heaven, understand something from the very magnitude of things, their motion, arrangement, constancy, beauty, and proportion, and that this could not possibly be if it were not established in wonderful order, having been fashioned on some greater design." St. Athanasius, writing shortly after that, says, "Creation, as if in written characters and by means of its order and harmony, declares in a loud voice its own master and creator." And then he goes on to say, "God, by his own word, gave to creation such order as is found therein, so that though he is by nature invisible, men might be able to know him through his works." St. Gregory of Nyssa, writing in the late 4th century, says, "All creation, and above all, as Scripture says, the orderly arrangement of the heavens, demonstrates the wisdom of the Creator through the skill displayed in his works." St. Cyril of Alexandria, writing in the mid-5th century, and this is the last personal quote, says, "From the origination of the world, from the fact that it exists as being, and from its order and beauty, we can recognize that the wisdom and power of him who created it and brought it into existence far surpasses every created mind." Moreover, this orderliness, all of them talk about the orderliness of nature, as well as its harmony, beauty, and lawfulness. Moreover, this orderliness of nature is a lawful order. And if there's a law, there must be a lawgiver. God was the lawgiver not only to the people of Israel, but to the cosmos itself. God says in Jeremiah 33:25, "When I have no covenant with day and night, and have given no laws to heaven and earth, then too will I reject the descendants of Jacob and of my servant David." Psalm 148 tells of God establishing the sun, the moon, the stars, and the heavens by a decree or law. In fact, the very concept of laws of physics, mathematical laws of the universe, has Christian roots. It comes from two great scientists of the 1600s, René Descartes and Isaac Newton. who based the idea of laws of physics on the idea that God imposed laws upon the material world. Some atheists concede this. For example, the eminent biologist Edward O. Wilson, who died, I think, a year or two ago, Harvard biologist, suggested the following as the reason that ancient Chinese civilization, for all its impressive scientific achievements, did not produce a Newton or a Descartes. He said, why no Descartes or Newton? Their scholars had abandoned the idea of a supreme being with personal and creative properties. No rational author of nature existed for them. Consequently, the objects they meticulously described did not follow universal principles, thoughts in the mind of God, so to speak, and therefore little or no search was made for them. By the way, he said he was an agnostic, but he probably was an atheist. The well-known cosmologist Andre Linde, who is also not a theist, once suggested that the idea of a universe governed by a, quote, single law in all its parts is historically rooted in monotheism. Now, the biblical religions did, too, of course, teach that there are supernatural realities that have effects in the world. An example would be grace. But the word supernatural, which means above the natural, would make no sense unless there were a natural order in the first place. And the concept of miracles, which are extraordinary events that go beyond what is naturally possible, presupposes that there is a natural order that determines what is naturally possible and what isn't. There's no contradiction logically between the idea of miracles and the idea of a lawful universe. For the same lawgiver who established the laws of nature can also suspend or override them. Because he made the rules, he set the rules, he can make exceptions to them for the sake of some greater purpose. As we'll see, the men who led the development of modern science in its first few centuries, the pioneers in uncovering the lawfulness of nature, including Descartes and Newton, were almost all devout Christians who believed in miracles. Now, there's a lot of confusion today, even among religious believers, about how nature relates to God. Instead of seeing God as the author of nature, they see God and nature as somehow opposed to each other or in competition with each other. So that if something has a natural explanation, that means that God has nothing to do with it. And conversely, if God is the cause of something, it must be supernatural. Many people, therefore, look for evidence of God, and this is not atheists only, but many religious people. They look for evidence of God only in what is outside the course of nature or inexplicable by science. That is, in the gaps in our scientific understanding. Hence the well-known expression, the God of the gaps. And atheists think that by closing those gaps in our scientific knowledge, they will leave no place for God to hide. Now, the traditional Christian view is quite different. If God is the creator of the natural world and established its laws and gave things their natural powers, his existence is evident in nature itself and in its ordinary processes. Medieval theologians distinguish two ways in which God acts in the world. He can act directly in a supernatural manner, for example, turning water into wine, or he can accomplish his will through the operation of natural causes and processes, which in the terminology of theology are called secondary causes. It has always been the Christian view that God ordinarily acts through natural secondary causes. In the words of the great theologian Francisco Suarez, who died about 400 years ago, God does not, quote, God does not interfere directly with the natural order where secondary causes suffice to produce the intended effect. Just want to see what slide I'm on. Yeah, this is the misconception that the people have. Now, this principle that God generally, ordinarily works through natural causes, was important for the founding of science, for it implied that when we're confronted by some puzzling event or new phenomenon, we should look first for natural explanations. Superstitious people tend to see the supernatural in every unusual or strange event. But this was strongly criticized by the great medieval scientist, theologian Nicole Oresme, who was also a bishop. He's also a scientist and mathematician of genius, as is generally recognized. In explaining the marvels of nature, he said, "There is no reason to take recourse to the heavens or to demons or to our glorious God as if he would produce these effects directly, any more than he directly produces those effects whose natural causes we believe are well known to us." Another great medieval scientist, philosopher, Jean Buridan, who's actually Oresme's teacher, wrote, quote, "The philosophers," and in those days that includes what we would call scientists. Scientists then were called natural philosophers. He says, "The philosophers explain such marvels by appropriate natural causes. But common folk, not knowing of causes, believe these phenomena are produced by a miracle of God, which is usually not true." In other words, for Christians, the default explanation of events is natural causes, not the miraculous. That's why the Catholic Church, for example, does not declare purported miracles of saints to be worthy of belief until it has excluded the likelihood of natural explanations. So this brings us back to the crucial theological distinction between primary and secondary causality. I think the failure to grasp this distinction is the main reason that some people see a conflict between science and religion. This distinction is most simply explained, I think, by a simple analogy and by using the terms vertical and horizontal cause rather than primary and secondary cause. The analogy is to a play or a novel. Let's take, for example, the play Hamlet. Now, in the play Hamlet, the character Hamlet kills the character Polonius, who is hiding behind a curtain eavesdropping, by stabbing him through the curtain with a dagger. So we can ask, what caused Polonius to die? And sometimes I've taken votes with audiences, but I won't here. Did Polonius die because Hamlet stabbed him through the curtain? Or did Polonius die because Shakespeare wrote the play that way? See, it's an absurd question. It's absurd to have to choose. They're both explanations of why Polonius died. They're both causes. Hamlet stabbing Polonius is the cause within the plot of the play, which we can call the horizontal cause, where Shakespeare is the vertical cause. He is the cause of the whole play and of everything that happens in it. He is the reason that there is a play. He's the reason that it has the characters Hamlet and Polonius in it. He is the reason that Hamlet stabs Polonius and that Polonius dies thereby. He is the cause, Shakespeare is the cause of every character and event in the play and all their mutual relationships, including the causal relationships within the plot. And that in no way, saying that Shakespeare is the cause of all of this, in no way diminishes the fact that within the plot of the play, Hamlet indeed is the cause of Polonius's death. Now, when we apply this analogy to the universe, traditionally, God was seen as the primary cause, as the author of the whole universe and its plot, whereas the causes within the plot of the universes are what are called secondary causes. There's no competition between these two. That's why, for example, it's absurd to treat evolution and creation as somehow competing explanations, the way both atheists and fundamentalists do. Did this species of animal, crocodiles, giraffes, whatever, hippopotamuses, did they arise through a chain of natural causes? Or did they arise because God wrote the script of the universe that way? Both. For Catholics, the answer is both. By the way, this has always been the Catholic view. For example, a few years after Darwin's Origin of Species appeared, Saint John Henry Newman, who is regarded by many as the greatest Catholic theologian of the 19th century, argued that evolution was in no way contrary to theism. He wrote, if secondary causes are conceivable, an almighty agent being supposed, I do not see why the series of such causes should not last for millions of years as for thousands. It also makes clear this distinction, why scientific materialists are wrong to think that theists believe in God, quote, without evidence. For a materialist, evidence consists that something exists, consists of one of two things. It's either direct sensory perception that the thing exists, or inferring that something exists that we don't perceive as the cause, as the natural cause of something that we do perceive. So we directly sense, you might say, that a compass needle moves. But we infer that there's something called a magnetic field that is the natural cause of the compass needle moving. And so that we infer the existence of the magnetic field in that way. But God cannot be, his existence cannot be known in either of these two ways, seen in either of these two ways, because first of all, God is not a part of the natural world, like a compass needle. It could be sensed. Nor is he a natural cause within the universe, like a magnetic field. He is not a cause within nature. He is the cause of nature. Thus, nature gives evidence of God in the same way that a play or a novel gives evidence of its author, even if the author is not in the plot of the novel. Or the way a musical composition, a symphony, testifies to the existence of a composer, even though the composer cannot be seen in the notes. He is not among the notes of the symphony. It's not a part of the symphony. So now let's return to the materialist historical critique of religion. The idea that Christianity, and the Catholic Church in particular, opposed science and tried to hold it back. I want to make sure this is the right slide. No, that's Newman. Okay. I'm glad I looked. The idea that Christianity and the Catholic Church in particular opposed science and tried to hold it back is called by historians of science the conflict thesis. It has been rejected by contemporary historians of science as a recent invention. The idea that science was born in conflict with religion and that there were two warring camps, the religious camp and the scientific camp, is projecting onto the past ideas that only arose in the late 19th century. In the first few centuries of modern science, the scientific people and the religious people were, for the most part, the same people. Consider the great figures of the scientific revolution. The scientific revolution was sparked by Copernicus, really, in the 16th century, but the century where the scientific revolution really took off was the 17th century. So let's look at some of the leading figures. In fact, these are virtually all the leading figures of the scientific revolution. Copernicus was an official of the Catholic Church. Johannes Kepler, famous for his 3 laws of planetary motion, was a devout Lutheran who announced his discoveries with this prayer: "I thank you, Lord God, our Creator, that you have allowed me to see the beauty in your work of creation." Galileo, despite his troubles with the church, remained a devout Catholic throughout his life, by all accounts. Descartes believed in God and that human beings possess immaterial spiritual souls and professed himself a sincere Catholic. Blaise Pascal was not only a mathematician and physicist of genius, but a Catholic whose life had been transformed by a mystical experience and who wrote in defense of Christian faith against religious skepticism. Robert Boyle, the first modern chemist, considered the founder of chemistry, was a pious Anglican who wrote theological works and left a large sum of money to endow a series of lectures whose purpose was to combat religious unbelief. Boyle said that he liked to perform experiments on Sunday because scientific experiments were a form of worship. Isaac Newton, the greatest of them all, spent as much time on theological and scriptural studies as he did on science. All of them saw their work as showing the beauty of God's creation, rather than as supporting atheism. Now, I could go through many other figures of the scientific revolution of the 17th century, and I list a whole lot of them at the bottom. All of those figures were devout Christians. It's very hard to find any of them who were atheists at that time. So science was not born as a reaction against religion or in opposition to religion. Science was created in what we call science was created in the 16th and 17th centuries by people who were almost to a person devout religious people. Moreover, the scientific revolution did not spring from thin air. Its foundations were laid in the universities of medieval Europe. The university was invented in the Middle Ages. And of course, the first universities were Catholic institutions. And the distinguished historian of science, Edward Grant, said it was in the universities of medieval Europe that science was first institutionalized, as he put it. It received, for the first time, an institutional foundation. By the end of the Middle Ages, there were 100 universities in Europe, and they produced hundreds of thousands of graduates who were introduced to scientific questions and from whose ranks scientific talent could emerge. The scientific community and the scientific public these universities created were the soil in which the scientific revolution germinated, in which the seeds of the scientific revolution germinated. Now, a little-known fact that dramatically illustrates the positive role the Catholic Church has played in the development of science is the large number of Catholic priests who made major discoveries. I'm not just talking about priests who did science. I'm talking about priests who made major breakthroughs in science, in some cases founding entire branches of science. Now, from the 17th century, I'll mention only Stenson, Mersenne, Scheiner, Riccioli, Grimaldi, Castelli, and Cavalieri. Niels Stenson, also known as Steno, Nicholas Steno, is famous in 3 branches of science: anatomy, crystallography, and geology. He was the greatest anatomist of his time, and he made major discoveries about the glandular and lymphatic system, as well as about the heart and the brain. In fact, several parts of the human body are named after him: Stenson's vein, Stenson's duct, and so on. But his greatest achievement was developing the theory of sedimentary rocks and the origin of fossils, which unlocked the history of the Earth, and for which he is regarded as one of the principal founders of the science of geology. So go and Google the history of geology and see who are the founders, and Stenson, or Steno as he's usually called, is listed usually first. Now, he was a convert to Catholicism. He was Danish by birth and Lutheran by upbringing. He became a priest and was eventually made a bishop. He was known for his rigorous asceticism and concern for the poor, and he was declared blessed by Pope John Paul II. Marin Mersenne, a friar of the Mennonite order, is considered the founder, along with Galileo, is considered the founder of acoustics, the science of sound, for fundamental discoveries in the theory of sound and vibrations. For example, he was the first person to measure the speed of sound. He also made important contribution to the theory and design of reflecting telescopes. But his most important role was as an organizer of the scientific community. His religious house became a meeting place of famous scientists. And his voluminous correspondence with other scientists was an important means by which scientists learned of each other's work. In those days, they didn't have scientific conferences, they didn't have scientific journals, and they certainly didn't have the internet. So how did scientists learn about each other's work? It was through correspondence, and the hub of that correspondence was Marin Mersenne. And that's why the Dictionary of Scientific Biography calls him one of, quote, the architects of the European scientific community. He was at the very center of scientific life in Europe in the 17th century. Christoph Scheiner, a Jesuit astronomer, was one of the first, was one of the co-discoverers of sunspots, and he made the most detailed study of them. Here's one of his diagrams. I think that's one of his diagrams. No, that's him. That's him. And I think that's one of his diagrams from his very massive treatise on sunspots. Another Jesuit astronomer, Giovanni Battista Riccioli, developed an extensive, he was an astronomer, he developed an extensive star catalog. He developed methods for measuring time precisely in experiments using pendulums. He was the first person to measure the acceleration of gravity on the Earth's surface, what physicists call now by the letter little g. He's the first person to make an accurate measurement of that. Most remarkably, Riccioli discovered and discussed in detail the effect in physics that we call the Coriolis effect, after Coriolis, who discovered it in the 19th century, but actually it was discovered 2 centuries before Coriolis by Riccioli. Grimaldi, Francesco Grimaldi, who worked with Riccioli on many things, discovered the extremely important physical phenomenon. That's the map of the moon. Grimaldi and Riccioli were the first to map the surface of the moon. But Grimaldi is also the discoverer. Those who are physicists in the audience may be surprised to learn that the extremely important phenomenon of diffraction of light in particular, was discovered by Grimaldi in the 17th century. He's the one that named it diffraction and did very careful studies of it. Now, because it shows that it was not understood till later that this shows that light is made up of waves. Now that we know that all particles are waves, because quantum mechanics tells us that, diffraction is an important phenomenon in all branches of science, but it was discovered by Grimaldi. The Benedictine priest, Benedetto Castelli, a friend and student of Galileo, did foundational work in hydraulics and fluid mechanics. He had 2 very famous students, Torricelli, who discovered the principle of the barometer, and Bonaventura Cavalieri. Bonaventura Cavalieri, who was himself a priest, made important advances in the development of integral calculus. Now, calculus was independently discovered by Isaac Newton and Leibniz. And here's a quote from Leibniz paying tribute to Cavalieri's work. He says, "The sublimest of geometry, the initiators and promoters were Cavalieri and Torricelli, later others. meaning himself, Leibniz, progressed even further based on their work. Spallanzani, Lazzaro Spallanzani, is considered one of the leading biologists of the 18th century, and his contributions to biology are too numerous to mention. René Just Oey, who lived at the time of the French Revolution, is considered one of the founders, if not the founder, of crystallography. He discovered the fundamental mathematical rules governing crystal structure, classified crystal structures of all the minerals known in his day. In fact, he had an atomic theory to explain crystal structure, which turned out to be correct. In the 19th century, Father Giuseppe Piazzi, yes, made many contributions to astronomy, including discovering the planet Ceres. Now, when he discovered Ceres, he called it a planet. Later, some decades later, it was reclassified as an asteroid. But it really isn't an asteroid, and so actually, in recent times, it's been classified again as a dwarf planet by astronomers on the same level as Pluto, which has also been reclassified as a dwarf planet. So Ceres was, and those are some pictures of Ceres taken with the Hubble Space Telescope and then from a satellite that NASA sent in orbit around Ceres. So he discovered that planet. It's the largest body in the asteroid belt. The Jesuit priest Angelo Secchi is considered one of the main founders of astrophysics. Now, astronomy is a very ancient science and is concerned with where things appear in the sky and when they appear. Astrophysics goes deeper to inquire what is causing these phenomena, what makes stars shine, how did they form, what's the physics behind all of this. And one of the principal tools that astrophysics uses is spectroscopy. We can tell what stars are made of by looking at studying the spectra of light from those stars. And one of the chief, and really the pioneer in doing this was Secchi. In fact, he is the first person, he developed the first classification of stars based upon their spectra, which was later superseded by one developed at Harvard, which was sort of based on his classification. But he was a pioneer of astrophysics. A beautiful symbol of the harmony of faith and science is the fact that Secchi did some of his groundbreaking research using an observatory built on top of the Church of Sant'Ignazio in Rome, and there's a picture of that. I have only three. Bernard Bolzano was a Czech priest who helped put modern mathematics on a more rigorous foundation. The Stanford Encyclopedia of Philosophy called him an outstanding mathematician and perhaps the greatest logician of the period from Leibniz to Frege, which is a 200-year period. So he's a major figure in the history of logic and mathematics. And then, of course, there's Gregor Mendel, who founded the science of genetics. And last but not least, the person I asked you about at the beginning, who was standing with Einstein, is the Belgian theoretical physicist, mathematician, and Catholic priest, Georges Lemaitre, who is the person who proposed the Big Bang Theory. He's considered the father of the Big Bang Theory of cosmology. So anyway, I'm going to stop there with the roster of great priest scientists. What a glorious record of achievement, entire branches of science founded by Catholic priests. Professor Lawrence Principe of Johns Hopkins University, a leading historian of science, has written that, quote, the Catholic Church has been probably the largest single and longest-term patron of science in history. By the way, I want to plug the website of the Society of Catholic Scientists, where you will not only find a lot of interesting articles and answers to many common questions about science and faith, but we have short biographies of 95 important scientists of the past who were believing and practicing Catholics. I urge you to go and visit that part of the website. Okay, so in the last part of my talk, I'd like to mention just a few discoveries of modern physics that seem more in line with a Christian view of the world than with materialism and atheism. And I'm running out of time, I have, I think, probably about 7 or 8 minutes until it's an hour. So for an in-depth discussion of these, I refer you to my book, Modern Physics and Ancient Faith, and also to the website of the Society of Catholic Scientists. Now, one discovery of the 20th century has to do with the beginning of the universe. The Jewish and Christian view that the universe had a temporal beginning, it has a finite age, was in opposition to us, in contrast to the view of the pagan philosophers of antiquity, including Aristotle, who believed that the universe had always existed. The pagan philosophers believed the universe had infinite age. And most modern atheists have also preferred that idea, that the universe had no beginning. As of 100 years ago, the scientific evidence seemed to say that the universe had always existed, or at least, let's say, at the beginning of the 20th century. The evidence, almost all of it, seemed to point to the universe having always existed. And many people came to regard the idea of a beginning as just a relic of religious mythology. But now we know that Georges Lemaitre's idea of a Big Bang is correct. There was a Big Bang about 14 billion years ago. Now, in the standard theory of cosmology, in our standard current theory, the Big Bang was the beginning of the universe and of space and time itself. So time began at the Big Bang in the standard view. Now, it is quite possible that something existed before the Big Bang, and there are speculative scenarios where that is, very interesting ones, where that is true, assumed to be true. But even if that is the case, turns out to be the case, the scientific arguments now, the theoretical arguments, strongly favor the idea that the universe had a beginning at some point, if either at the Big Bang or at some earlier point. But there's strong theoretical arguments in favor of the universe having had a temporal beginning. A second discovery has to do with our place in the universe. For a long time, atheists have said that the evidence shows that human beings are just a cosmic accident, a fluke in a universe that is totally without purpose. But over the last few decades, physicists have become increasingly aware that many features of the fundamental laws of physics and the structure of the universe are just right, seem to be just right, to make the existence of life like us possible. If certain things had been even slightly different about the laws of physics, then we wouldn't be here. These fortuitous features are often called anthropic coincidences, anthropic coming from the word for man. It's kind of a misnomer, but they're the coincidence that make it possible for life, complicated life, or life of any kind to exist. Now, they suggest to many people that we aren't an accident and that the universe does have a purpose, namely that beings like ourselves should arise in it. Now, I could give many examples. In my book, I give about a dozen in great detail of such fortuitous anthropic features of the universe and its laws. For one example, famous one, is if the strong force, as it's called, which holds atomic nuclei together, were slightly weaker, about, let's say, 25% weaker than it is, then none of the elements of the periodic table would exist except hydrogen, which means you wouldn't have any life, chemical-based life. Another famous example is that the nucleus of the carbon-12 has an excited state, an energy level, whose energy is just right to enhance a certain process that takes place in stars that produces carbon. Now, if this energy level had been different in energy by even 1% or so in either direction, that process would not have been enhanced, and there would be almost no carbon or any elements heavier than carbon in the universe, and so no carbon-based life, almost certainly no chemistry-based life. The strength of the Higgs field, you've heard of the Higgs field, Higgs boson. The strength of the Higgs field, it turns out, has to be tuned to a fantastic precision if life is to exist, and so on. And it's not just certain quantities seeming to be fine-tuned to make life possible. Certain gross qualitative features of the universe are crucial as well. The fact that the world is quantum mechanical is very important for the possibility of life, as is the fact that the number of large space dimensions is 3 and not smaller or larger than 3. A very interesting case is the size of the universe. Now, many people have seen the vast size of the universe, both in time and in space, the vast scale of the universe, as proving that we're insignificant in the cosmic scheme. But actually, the vast size of the universe is a precondition for our being here. It takes billions of years for the chemical elements needed for life to be synthesized inside stars. And it takes billions of years, once you have those chemical elements, for evolution to produce complex multicellular creatures like us. So you need the universe to last for billions of years to end up with creatures like us. But according to Einstein's theory of gravity, the longevity of a universe is tied very much to its size. If a universe is to be able to last for billions of years, it has to achieve a size at least as large as ours is. Suppose you said, the universe, why didn't God create a universe that was only, say, a few thousand miles across? That would have been enough room for us to live. Yes, but such a universe would only have lasted for about 1/100th of a second. Even if the universe were allowed to be the size of the solar system, it would only have lasted for a matter of hours. A universe that is to last billions of years must have a size of at least billions of light years across, which is what we see our universe to have. So the vastness of the universe is not a sign of our insignificance, but a precondition for the universe to have beings like ourselves in it. There's a naturalistic way to account for the anthropic coincidences, or some of them, which is called the multiverse idea, which is a very interesting idea. And I think there's a very good chance that we live in a multiverse, but I don't have time to talk about that now. I will talk about it in private or in the Q&A if you want. A third development is that the physicists have found that the laws of physics are based on very deep mathematical ideas. To give an example, 400 years ago, Kepler discovered these 3 beautiful mathematical laws of planetary motion. Now, they are beautiful, but they're not deep. You could explain Kepler's laws to say, a middle school student or a 6th grader in maybe 15 or 20 minutes. A little bit of geometry, a little algebra. But we now know that Kepler's laws are based on deeper laws, Newton's laws of mechanics and gravity. Now, to understand Newton's laws of mechanics, you have to know calculus. In fact, Newton invented calculus precisely in order to formulate his laws of mechanics. Well, calculus now you're talking about is, say, a college freshman or a high school senior, perhaps. Much more sophisticated mathematics. Now, Newton's laws of gravity are actually now known to really be an approximation to something much deeper, which is Einstein's theory of gravity. Now, Einstein's theory of gravity uses ideas like non-Euclidean, curved, 4-dimensional space-time, and you need such things as tensor analysis and differential geometry to understand it. So we're talking about much deeper mathematics. And now we think that Einstein's theory of gravity is based on something yet deeper, probably something called superstring theory. And superstring theory is so deep mathematically that even since what was called the superstring revolution in 1984, since which time hundreds and thousands of the world's most brilliant mathematicians and mathematical physicists have been intensively studying superstring theory, they do not claim to fully understand its mathematical structure because it is so deep. Doesn't this suggest that a mind much greater than ours came up with these laws? The more deeply physics has probed the inner workings of the physical world, the more profound and intricate the mathematical structure that it has uncovered. The architecture of the physical world is not based on mere amalgamation of simple stuff. but on mathematically rich ideas, subtle ideas. As the great 20th century physicist Sir James Jeans remarked many years ago, the universe begins to look more like a great thought than a great machine. And in 1932, or I guess he gave the talk in 1931, the great mathematician and mathematical physicist Hermann Weyl said in a lecture at Yale University, "Many people think that modern science is far removed from God. I find, on the contrary, that it is much more difficult today for the knowing person to approach God from history, from the spiritual side of the world, and from morals. For there we encounter the suffering and evil in the world, which it is difficult to bring into harmony with an all-merciful and almighty God. In this domain, we have evidently not yet succeeded in raising the veil with which our human nature covers the essence of things. But in our knowledge of physical nature, we have penetrated so far that we can obtain a vision of the flawless harmony that is in conformity with sublime reason." Now, because of time, I'm going to skip the fourth development in modern physics that I was going to talk about, which is that quantum mechanics has a couple of very profound philosophical implications, or at least it has been argued that it does. And according to some very eminent physicists, the logic of quantum mechanics is incompatible with philosophical materialism. And that has to do with what's called the measurement problem in quantum mechanics. In quantum mechanics, which is the fundamental framework of all of physics, it's not just a theory of this or that. It is the grammar, it is the fundamental language of all of physics since the 1920s. In quantum mechanics, one talks about two types of things. One talks about physical systems, on the one hand, where those are the things you make measurements of, those are the things you make calculations about. And then there are what are called the observer, or observers, who are the ones who make the measurements. So they're the systems that are measured, but there are the observers. They make the measurements. It turns out that if you try to describe everything, not just physical systems, but observers in toto, physically, if you try to say that the observer is purely a physical entity, completely described by the equations of physics, you run into some circularity and some inconsistencies. And that's why you have, for example, the great physicist Sir Rudolf Peierls. Well, I have the quotes up there. In the case of quantum mechanics, if one no, that's Halvorsen. I think it's, well, anyway, I'll let you read the quotes. One is by Eugene Wigner, Nobel Prize winner in physics, who said that quantum mechanics is inconsistent with physicalism, and Sir Rudolf Peierls said something amounting to the same thing, and Hans Halvorsen, a distinguished philosopher of physics at Princeton University, said that if you are a physicalist, everything is described by physics, you run into the measurement problem. That's the circularity that I was talking about. So I'm going to stop there and just summarize. Not only has religion, and Christianity in particular, including the Catholic Church, been a great friend of science and played a very positive role in its history, but the things discovered by science, contrary to what many people think, have actually in many ways tended to agree with some fundamental religious ideas about the universe and our place in it. So that's where I'll stop. Thank you very much. Oh, sure. I went a little long.
I think I can bring this around if there are questions.
My eyesight's not the best, so if you can pick the hands that go up.
Yeah, I'll run over.
I like questions about physics because they're easier to answer than questions about theology. I'm a physicist, not a theologian, but I'll try to answer theological questions too. No questions?
Yeah, you just that's a little loud. Okay, you mentioned that you think like kind of the idea of of multiverse theory is something you think is likely. Could you just maybe, if you can, explain quickly what you mean by a multiverse theory and then why you think it's likely? I guess.
Okay, so the question is about multiverse theories, which I didn't get into in my talk. So, it's now generally admitted by even atheists that there are many. The late Stephen Hawking, for example, admitted this in his last book, that there are many features of the laws of physics, as I said, that are just right, seem to be just right to make life possible. This includes things such as the strength of certain forces, the masses of certain particles, and so forth. Now, the multiverse idea says not that there are many universes necessarily. That's kind of a misconception. A multiverse is a kind of, it's saying something that the universe has a kind of multiplicity to it, that has different regions. There are different parts of the universe in which things are very different. So that, for example, in one part of the universe, the part we can see, so what's called the observable part of the universe, the strong force might have a particular strength, but very far away, in other parts of the universe beyond our horizon, which we cannot see, the strong force may have other values. It may be stronger here and weaker there, and so on. Similarly, I mentioned the energy level of the carbon-12 nucleus. That might be different in different places. Or the strength of the Higgs field, I talked about that. So the idea is things that we might have traditionally we have thought are constants of nature, actually might vary from place to place in the universe. And so it becomes a lottery. That is, imagine the universe is enormously big. It doesn't have to be infinite, but imagine it's exponentially larger than the part we can see. And imagine that all these quantities in the laws of physics are varying throughout this enormous universe. There might be, it's bound to be, so the argument goes, that there is some part of the universe where all of these quantities happen to take the right values for life. And that's not an absurd idea. Something similar happens with habitable planets. Somebody didn't know that there were other planets and thought Earth was the only place. Would say, isn't it amazing that so many conditions on Earth are just right for life? It's not too hot, it's not too cold, the gravity's not so strong as to crush us, it's not so weak as to cause the atmosphere to leak away, and so on. The right chemicals are present on Earth, and so on. Wow, isn't it amazing all these conditions are just right to make life possible? But it's not quite as amazing now that we know that there's a vast, exponentially large number of planets in the universe with all sorts of temperatures and gravities and so on, and chemical composition. So if you have a huge number of planets, it's not so strange that some of them will have conditions that are just right for life. Well, that's the multiverse idea takes that one step further and says that the universe has many domains or regions where even things we thought were sort of fundamental quantities actually take different values. And that's not an absurd idea. I don't think, however, that it completely vitiates the argument that there's some evidence that the universe has a purpose which includes life. And the way I look at it is this. For a universe to be a multiverse, for many fundamental quantities to be able to vary from place to place in the universe, like the mass of the electron, for example, or the strength of the strong force, the deepest laws, by the way, all physicists who think about multiverses assume that the whole multiverse is governed deep down by a single set of laws that are the same everywhere. The most fundamental laws are the same everywhere. And those laws have to be very strange and very special if they are to allow a lot of quantities like that, fundamental quantities, to vary from place to place. So I think the takeaway lesson, whether you believe in a multiverse or not, or take it seriously or not, is if you are going to have a universe that can support life, the laws of physics the fundamental laws have to be special in one way or another. They can be special in having certain quantities precisely chosen to be just the right values, or they can be special in being the kind of fundamental laws that allow those quantities to vary all over the place. But we should be amazed that the universe can have life in it. Not any old universe based on any old laws is going to have that feature. The fact that the laws of physics are rich enough and such that they allow for life to exist is a very remarkable fact about the laws of physics. And I think no physicist today who's paid any attention to these things would doubt that, including Hawking, well, it's now more recognized.
Hi, so I thought that was a really cool talk. I was just curious because you mentioned a lot of like the Renaissance and like scientific revolution.
What? I'm sorry.
So you were talking a lot about the scientific revolution and the priest. I was just curious, what would you say to someone who questioned whether all of these people were priests because that's how you got a formal education in like that time? Where I noticed that you kind of stopped and kind of like phased out by the time you got to modernity. So like you talk about like the 1930 and the Big Bang founder, but now that there's a lot more, say, access to education, right? We have people like you, obviously, who are religious and into your faith. Right. But yeah, I don't know if there's any response.
I understand your question, yes, and there's some truth to what you're saying. That is, certainly in the Middle Ages, well, in the Dark Ages, the real Dark Ages, would say from 500 AD to 1000 AD, when civilization had collapsed after the fall of Rome, almost the only people who could read and write were the clergy, the Catholic clergy. By the way, that's why clerical means both people who can like do clerical work and also means clergy, because there was a time when only clergy could read and write. And in the Middle Ages, it's true, and even more recently, probably in the 17th, 18th century, in Catholic countries, the clergy were very prominent among the more educated class of society. And it's also true that one of the few ways that people who were from poor backgrounds could advance was by becoming a priest. And you could get a high degree of education and rise in the church, even if you came from very humble origins. That was one of the few ways you could be upwardly mobile. However, a lot of the priests I mentioned were from much later. So, for example, Georges Lemaitre was in the 20th century, the founder of the Big Bang Theory. Gregor Mendel was in the late 19th century. Secchi was in the early 19th century, and so on. Bolzano was in the mid 19th century. So I gave a lot of examples from then. But even if we're talking about the 17th century, there are plenty of lay people doing science. But there are certainly some priests who are scientists where one might think, well, maybe they only became priests for the educational benefits of it or something. But actually, I took pains to only mention priests where we know that they were sincerely religious and devout and believers. My point is not to say that priests are better at doing science than lay people. My point is that the Catholic Church, if the Catholic Church as an institution were really hostile to scientific enterprise, you would not have found so many of her officials and clergy engaged in it. Religious orders allowed their priests, encouraged. So you find many Benedictines, for example, and many other religious orders doing scientific research. So the church obviously thought that doing science was not only something that was a fit occupation for a Christian, but a fit occupation for a priest. And my point was not to say that somehow priests are better at it than other people. They're not. Now that education is more widely available, also nowadays it's very hard to be a priest and a research scientist because it's a lot of years of training to be a priest and a lot of years of training to be a scientist, and it's hard to do both. And so, but there are actually the Society of Catholic Scientists I haven't counted, but I would guess that there are probably among our 2,000 members, we probably have 50 or 60 who are Catholic priests, who are research scientists. So there are still plenty of scientists around today who are priests. But I'm just trying to make a point about the church's attitude towards science.
Another question.
Yeah.
I'll try to formulate it, keep it some, precise. The idea that fundamental particles pop in and out of existence through time currently, and also in the past, is there any corollary reasoning behind the idea of creation as God created it back in time, affecting the present now, and him continually creating?
Okay, so there's bad acoustics in here, but let me just say, I'm not sure I heard exactly the question, but I think one should not think of creation, as many people do, as something that happened a long time ago at the beginning of the universe. Though it is true that the book of Genesis says, in the beginning God created. And so many people identify creation as something that happened in the beginning. But actually, Catholic teaching is more sophisticated than that. One should really distinguish between the creation of the universe and the beginning of the universe. And somebody who did this very clearly was St. Thomas Aquinas, for example. He believed that God could... So the way to see that there's a distinction is to think, for example, of a piece of music. The beginning of the piece of music has an internal sequence. And the beginning of the symphony are the first notes in that sequence. They're just a set of notes at the beginning of the sequence of notes. The creation of the symphony is what happens in the mind of the composer. And the composer doesn't just create those notes at the beginning. The composer creates every note of the symphony. So every note is equally created by the composer. And the way the Catholic Church understands creation is God conferring being on the universe. God is making the universe a real universe, not a hypothetical or fictitious or possible universe, but a real universe. And God is making this real right now. This has reality, it has being. And God is conferring that being upon it, making it real. And God, so everything in the universe, in the whole history of the universe, throughout space and time, is equally created, held by God in being, equally being created by God. So creation is not actually something directly connected with the first events of the universe. It's really something that pertains to the whole. That's why in the Creed we say God is the creator of all things, not just the things at the beginning. He's creating everything now and in the future and the past. Well, God is outside of time. So God's creative act is not something that happens at a particular time. God eternally, timelessly wills, this is the Catholic teaching, wills the existence of all created things in one infinite, in one timeless act of creation. So people who are trying to connect various ideas in cosmology, ideas about the beginnings of the universe, what happened near the Big Bang, or what might have happened before, thinking that they're actually talking about creation, are not. They're just talking about what happened at the beginning of the sequence. They're not talking about why there is a universe at all.
One more question.
Yeah, okay. Hawking, in a famous book that he wrote in the 1980s called A Short History of Time, I think it was called, he made actually the decisive point. He said, all that physics gives you, this is directly out of his book, all that physics gives you is a set of mathematical rules and equations. They cannot explain why there is a universe for those equations to describe. And that is when he was, now later in his life, he kind of went back on that. But at that point, he really nailed it. The question of creation is the question of why there is a universe at all and the equations of physics don't explain that. They don't, as he said, explain why there is a universe, a real universe, an existing universe for those equations to describe. Yeah.
Thank you. So a lot of Catholic theology and dogma and definitions is based on, takes a foundation in classical metaphysics.
It's based on what?
What'd you say?
It's based on what?
Takes a foundation in classical metaphysics.
I'm sorry.
At least the status quo.
This bad reverberation is based on
Classical metaphysics, like Aquinas and Aristotle, idea of substance and form and accidents and things like that. And so a lot of people that are opposed to science, or at least think that there's opposed to Catholicism or faith, would say that there's a tension between the philosophical foundations of faith and Catholicism, particularly classical metaphysics and science. So I guess I'm asking, do you believe that there is a tension there and that there's a duty then for Catholic scientists and philosophers to seek new philosophical foundations for our dogmatic beliefs, or do you think that there is no tension?
Catholic doctrine is based ultimately on revelation, divine revelation, as contained in Scripture and tradition. Now, in elucidating the contents of Revelation, so that's what it's based on. So in elucidating the doctrines of the church, the teachings of the church, theologians have made use at various times of various philosophical systems. So in the early church, Plato was very popular. And I think some aspects of Stoicism, but certainly Plato. Later, in the late Middle Ages, Aristotle became popular. But it is possible to be a completely Orthodox Catholic and not be an Aristotelian or a Platonist. So, I mean, I would disagree that the Catholic doctrine is based on these metaphysical systems. I think certain theological explications of doctrine make use of ideas from certain philosophical systems, but that's a different matter. I personally, for example, though, there are aspects of Aristotelianism that I find that I think are important and useful and true and useful for theology. There's a lot of Aristotle I think is in tension with modern science. So I think a lot of Aristotle is not consistent with modern science. And so I would agree with you that, but that I don't think really affects, but that's to say that Aristotle is in tension with modern science in some regards, which he is not the same as saying that Catholic doctrine is in tension with modern science, which I don't think it is.
Okay, I think we have to wrap it up then. Thank you, Professor Barr.
Okay.